Good day, everyone. I'm Dave Rubenstein, Editor-in-Chief of SD Times, and I want to welcome you to today's program, Best Practices for Limiting Downtime, How Exavolt Optimized Its Customer Experience Using Performance Monitoring. Before we get started, I have a couple of brief housekeeping announcements. There'll be a live Q&A period following today's session, and to ask a question, you would just go to your control panel, click on the Questions tab, type it in, hit Submit, and we'll get to as many as time will allow. Second, the session is being recorded and will be available on sdtimes.com tomorrow. So also, all attendees will be receiving a link in your emails to the recording, so you can replay it as you like. As we've been reporting in SD Times, performance monitoring has had to evolve from a practice that only trained ops professionals could do to a more democratic approach. This is because software is being delivered more quickly through Agile and DevOps practices and because of the complexity of new software architectures. Exavolt, a business file sharing company that's focused on automated file transfer, had some issues that were noticeable because their site was not as performant as their goals wanted it to be. So they needed a deeper view into the issues and how to resolve them. So here to talk about it are Tom Feit, he's the head of engineering at Exavolt, and David Orno, CEO at Exavolt. And with me now to kick things off is John Skog of Instana, which helped Exavolt improve its experience. Hello, John. Get us started.
All right. Hey, thank you for that nice introduction there, David. And thank you to everyone who has joined the webinar today. As David said, I'm John Skog, and I work here in product marketing at Instana. During the webinar today, I will discuss some of the changes that are happening in the industry, the challenges these changes are bringing, and how Instana was specifically designed to meet these challenges. I'll then hand the presentation over to David and Tom from Exavolt as they walk through some real use cases, challenges they've faced, and ways they're rising to the challenge to provide the best possible experience to their customers. As David mentioned, and just as a quick reminder, we will be answering questions at the end of the presentation, so please feel free to type the questions into the chat. And with that, I will go ahead and get started. For many years now, technology has been drastically changing the way organizations do business. We are now in a position where every organization needs to innovate quickly or they're going to die slowly. In order to keep up with the accelerated pace of change, to stay ahead of the competition, and most importantly, to meet the ever-increasing demands of customer expectations, every company, regardless of the industry they are in, is going through a digital transformation, right? As the State of DevOps report stated, delivering software quickly, reliably, and safely is at the heart of technology transformation and organizational performance. Because of this, we're seeing that there have been three major shifts or tectonic shifts that are impacting your business, and they are change, organization, and complexity. We are being asked to increase our deployment frequency with continuous integration, continuous deployments, automated testing, and doing things like canary deployments to ensure new releases don't negatively impact a large swath of our customer base. So with this technology, organizations are doing everything they can to automate each and every step of their build and release pipelines. And in order to achieve this, we've needed to change the way our organizations operate by bringing development and operations closer, focusing on value streams, software delivery performance, and following agile methodologies. And for this new DevOps organization to work efficiently, we need to provide them with new technologies and platforms. As organizations move away from the monoliths and service-oriented architectures of the past and move kind of more towards the cloud-native microservices running on containers or Kubernetes, the technical complexity grows exponentially. And with these three major shifts, we're seeing a whole brand new set of challenges that must be addressed, right? When you're running cloud-native containerized microservices, it can be nearly impossible to find the specific service you are looking for amongst the chaos. As a developer, trying to hone in on the performance of the specific services your application relies on can be an insurmountable task. Organizations often do a great job of automating build and release pipelines or creating automated CI/CD pipelines that ensure each step from commit to build, to test, to deploy is fully automated. But when it comes to monitoring, it is still a mostly manual process, leading to new services often being released without monitoring at all, or taking the otherwise fully automated pipelines and slowing them down or stopping to manually write monitoring code into the application or service just before deployment. We also hear from our prospects that services behave differently in production than they do in their test environments. So we've created these great automated tests throughout your pipeline. At each day, the service gets the green light to move on to the next stage. And then when the service goes live in production, it just doesn't behave the way we are expecting. And this often results in failed deployments or impacted users. All of the new technologies and platforms you've put into place produce metrics, and your services are making thousands or tens of thousands of calls, creating so much data that it is impossible for a human to make sense of it all. Throwing all this raw data into dashboards is not reducing the burden of understanding what is actually happening in your environment. And to make matters worse, this mountain of data and the number of services running often make finding the root cause of an issue exponentially more difficult. Back when we had these big monolithic applications, it was easy to pinpoint where an application went wrong and what its impact was. But with all of these different microservices running, getting a grasp of every service's interdependencies can be nearly impossible, making it difficult to decipher which service failed first, which service is breaking other services, and then you add on top of this a storm of alerts for each corresponding event that occurs, and it's really difficult to understand where to begin to alleviate the root cause because we're spending so much time fighting the symptoms, right? Fighting the individual events, not the main root cause of the problem. At this point, you might be wondering if making these major shifts is the right thing to do in the first place. And I'd have to say that the answer to the question is undoubtedly definitely a yes. Right? You just need to ensure that you provide your developers and operators with an easy way to make sense of the complexity and mountain of data that you have coming across these new systems and platforms. And this is the challenge that Instana was specifically created to solve. Instana has 6 core capabilities that help ensure your applications are running smoothly, regardless of the complexity of your environment. Instana, with little effort and zero configuration, automatically and continuously discovers, monitors, and analyzes your full technology stack, providing you with a holistic view of your entire environment. This ensures you gain a full understanding of your infrastructure, orchestration, and applications in your highly complex and ever-changing environments. With all of the data that Instana is gathering from these systems, we create what we refer to as a context guide. This is a model of all your service and infrastructure components that understand all physical and logical dependencies. The context guide enables you to understand the impact of any change and how issues and changes impact user experience over time. Application Perspectives offers targeted analytics, dashboards, and alerts that help you cut through the noise and complexity with fully customizable views. This helps you quickly get a series of curated dashboards that visualize and analyze all related services and infrastructure, making it easy for developers to hone in on the specific services and/or applications they care about. Pipeline Feedback gives you immediate automated feedback on every new release, deployment, and version with a full understanding of the impact of changes. Instana gives you full visibility into the whole development and deployment pipeline and the relationship between the code and quality. And then by combining dependency mapping, event correlation, and expert knowledge, Instana delivers automatic root cause analysis so you can immediately fix any service impact. Metrics, traces, changes, exceptions, logged errors, or anything else are all correlated to formulate a singular detailed understanding of why an incident occurred. And then by correlating all of the events that share context or have shared dependencies into a single alert, Instana eliminates the alert storms and allows the DevOps or SREs to dive directly into the cause and fix the issue, not the symptoms. And finally, with unbounded analytics, we allow you to generate new insights from your entire repository of application request data with infinite filtering capabilities. So you can identify and isolate individual or groups of trace or calls in whatever manner you want. This allows you to filter out the noise, drill down by application, service, endpoint, type, technology, latency, or any other tag that you desire. This makes it incredibly easy for DevOps or SRE teams to find optimization opportunities, kind of to fix problems before they arise to the customer base. All of these capabilities are designed to provide you with the best understanding with the least amount of effort, so you can deliver software faster with better quality. And with that, I'd like to pass the mic over to David Ordal. He's CEO of Exavolt, and he's going to discuss how they are navigating these new challenges while providing great customer experience. David, over to you.
Well, thanks, John. Yeah, so we have faced pretty much all of the challenges that John outlined on his slide, his slide that was just a couple slides ago, and it's definitely a changing world. Before I tell you about that, though, let me tell you about a little bit about Exavolt and kind of give you a background on sort of who we are and what we do, and then talk a little bit about our technology and our architecture, and then we'll sort of dive into some things at a technical level in a little bit more detail. So Exavolt is a business file transfer company. What we do is we help customers transfer large data files from point A to point B. So we're similar in concept to a Dropbox, to a Box, Google Drive, somebody like that. The big difference is that we focus on automated transfers. So meaning system to system transfer, rather than Mary in Chicago needing to send the latest marketing files to Bob in Tulsa. We have a system that facilitates automated transfers. 500 point of sale systems all over the Midwest need to report hourly data back to a central server, which can do analytics and reporting and things like that. For example, 30,000 trucks running all around the country have an Arduino device running on them, and that Arduino device needs to report hourly data on the truck's location, engine operation metrics, things like that, back to a central location, so that central server can do analytics and things like that. So we really, as I say, we really focus on the automated transfers, and to do that, we support a number of technologies that you don't typically anyway find in file transfer services. So, for example, Secure FTP, which is an older file transfer protocol. It's been around since I think the 1970s. It's an older file transfer protocol, but it's extraordinarily flexible and extraordinarily compatible with a lot of different devices. Passwordless logins, SSH key logins, another one. We allow these automated devices to automatically log in to our service with just a key, rather than having a human have to go in and type a username and password. So that's really our focus. We've been around since 2008. We're headquartered in Oakland, California. To give you a sense of the scale, we've got customers in 102 countries. So including most of the countries that most of us anyway have been to. So with that, John, if we could go to the next slide, I want to show a couple screenshots of our service to give you a little bit of background, and then talk a little bit about our stack. So here's our service. You can see there on the left. This is our web interface, and it's a pretty standard file transfer interface, right? You can upload files, you can download files, you can create folders, you can create users, you can set up notifications, on and on and on and on and on. So we've got that. We've got our FTP side, the secure FTP side, but all of it runs on a core API. So under the hood, this web interface that you're seeing here is really just a shell. It's not. There's nothing terribly complex about it. If our customer comes in and says, "Hey, I want to create a user," all it does is goes and talks to the API and says, "Hey, API, go create a user for this customer." If a customer says, "I want to rename this folder," it says, "Hey, API, go and rename this folder for this customer." So it's really just a shell, and where the fun stuff comes is our API and how that works. And so we use a variety of technologies in our stack. We have a lot of the APIs built on PHP. We've got some services running on Node.js. We've obviously got the FTP side daemon, which runs on ProFTPD. All of it's containerized using Docker. So it ends up being a fairly complex stack, which as you can imagine then starts to become somewhat complex from a monitoring standpoint. So if we go to the next slide, give you some stats on the API itself here. Our API it's perhaps not Google levels, but it's definitely there's some volume to it. We serve about 35,000 requests a minute. We do about 50 million calls per day. And the numbers, interestingly enough, the numbers are relatively constant throughout the day. So, if you think about these automated transfers, if a truck, 30,000 trucks are reporting data back hourly to a central server, they're doing that every hour of the day, right? Doesn't matter if it's 2 p.m. or 2 a.m. They're doing that every hour. So we do see a little bit of shift throughout the day, as in terms of in terms of the number of calls we get, but it's much more constant than you might otherwise see with a service, say like a Dropbox, where most people are using it as humans, and so there's going to be a lot of traffic in the morning, maybe some significant traffic in the afternoon, but by the time you hit 2 in the morning, it's dropped off pretty good. And so what that means from a monitoring standpoint is that the stability and the performance of the API is super critical. It wasn't obvious to me at first, but because of this automated focus, these customers are just as aware of an issue at 2 a.m. as they are at 2 p.m. Except then they're usually much more unhappy because now they're getting woken up by an alert from their own system that says, hey, we can't transfer files via Exavault, and you need to go do something about this. They're much more unhappy at 2 a.m. than at 2 p.m. And so it means if you have a downtime event, or if you have some performance problem, it means you've got it means you've got unhappy customers. Of course, it means you've got unhappy DevOps guys, because they they don't like getting woken up at 2 a.m. any more than the customers do. So it's sort of bad all around. And yet as John was saying, you've got these complex services that have a lot of different pieces that are sort of changing all the time. We release software, release updates to our software fairly frequently, and so there's not a there's not always a sort of a thing you can sort of say, oh well, this one specific thing did it, right? If there's a problem. So we had a period late last year, as David was mentioning, where we weren't quite meeting some of our internal performance goals. We weren't there were a couple instances of a small downtime, but a lot of it was just things were slower than they should be. We have a webhooks, for example, which is where we call out to your system to give you an update on that a file's been transferred or something's happened. And those are supposed to be fairly instantaneous. We had periods where there'd be 20, 30 minutes delayed, right? So our customers are coming to us and saying, hey, we uploaded this file, we haven't gotten the webhook notification, what's going on? So we identified the need to sort of figure out what to do about this and figure out how to fix it. And that's kind of where some of this APM technology comes in. So I want to talk here about the sort of the three core things that we identified as critical for us from a business side. I'm going to turn it over to my colleague, Tom Feit, who's going to talk a little bit more about the technical side and take you guys through sort of some of our decision process and some of the stuff that we've come up with. So the three things from the business side that we really focused on, we, number one, want to understand the impact of system and software changes. So, as I say, we release things very frequently, not quite constantly, but definitely, we could have sometimes, several releases, software releases a week in some cases, hot fixes and things like that. And so we release things frequently, and we need to know when something has changed is impacting system performance. We do a ton of testing, we do load testing, things like that, but there's always cases where some system or some service is performing in a way differently than you expected or differently than you saw in your test environments, and it's impacting customers, and you need to be able to know that. So that was one key thing. Number two, be able to troubleshoot issues quickly. I mentioned that we've got all these automated transfers. They're happening 24/7, and customers notice, extremely quickly when something's not right. We sort of joke internally that we're not sure what's faster, our customers or our monitoring system, in terms of letting us know there's problems. And full disclosure, that's not true. We have never had a customer let us know about an issue before our monitoring let us know, but it is sometimes really quick. Our monitors, our alerts will go off, and within minutes, we have customers on the phone or on our urgent emergency pager line, being like, hey, something's wrong, what's going on? We need help. So our customers notice very quickly, and we need to be able to troubleshoot issues very quickly, get in and figure out what's going on and get it fixed. And then not as obvious, and I think this is a little bit more sort of on the cutting edge level, but not as obvious, is the ability to monitor down to the user level. So most APM systems can monitor things at a high level. They'll be able to give you aggregate metrics and say, your database response time yesterday was for all queries was, X milliseconds, whatever it is, right? But not as many systems can monitor down to the user level to be able to go in and say, hey, let me show you what queries, what transactions, what activity this specific user had yesterday. And for us, that's proven extremely key because we'll get things where a customer will come in and they'll say, hey, you know what, last night my files were taking 50% longer to transfer than I expected, or than they used to, than they did the night before that. Or last night I was having some sort of trouble with X and Y and Z, right? And we look at all our global metrics and we're like, things look fine. We didn't see any alerts, all the graphs are straight, everything is good. What's the problem? That's the global metrics. But when you go into the user level and you're able to go into the user level, you can then go look at that user's specific transactions and say, well, wait a second. Yesterday, this guy's database queries for this particular query were taking 30 milliseconds. Last night, they were taking 12 seconds. So they went from 30 milliseconds to 12 seconds. What happened? And identifying things like that then allows you to go in and really try to figure out what the issue is for that specific user. And often it'll either reveal that the user is doing something unusual that you didn't expect or don't want them to do, or maybe there's an edge case bug, something that didn't come up in testing that this one particular user has hit. Your other, thousands and thousands and thousands of users are fine, but this one user has hit this, and you're able to go identify those and drill in and figure those out. So that's been a really key thing for us to understand what's going on at a user-specific level. So with that, I'm going to turn it over to Tom Feit, who's one of my senior engineers. We're going to start with a bad joke that gave us the title of our webinar, and then he's going to talk a little bit about some of the technical side of the APM stuff that we've been working on. So Tom, over to you.
Thanks, David. My name is Tom Feit, and I'm a senior engineer with Exavolt. And like David said, I'm starting off my section of the webinar with a very terrible joke. So here we go. A bug, a latency spike, and an end user walk into a bar. The bug orders a beer. The bartender slides the beer down the bar, and the bug simply watches it slide past and crash to the floor. The latency spike makes a huge deal about this and badgers the bartender about cleaning up the mess. The user, waiting and waiting and waiting, finally gives up and goes to the bar across the street and writes a bad review on Yelp. And this whole scenario could have been avoided if the bar had a bouncer who helped identify the bug and the latency spike before they caused problems. And that is where an APM solution comes in, because that can help identify issues before they become problems and before they impact customers. So at Exavolt, we have implemented a few different APMs over the years. And here are kind of the factors that we consider when we look for an APM to implement. And I'm not going to go through every single one of these because there are a lot of them, but I would like to call a few of them out. One of the things is breaking information down by account. And as David was talking about just a minute ago, we'll get customers who report issues that nobody else has. And looking at the aggregate information isn't good enough. We get everything looks normal and there's nothing out of the ordinary, but being able to filter the data specifically by customer accounts can show exactly what the customer is seeing and help us solve their problem. And that happens more often than not. We do have a lot of customers who will use the system in a different way or a kind of an edge case situation. And breaking in the information down at the account level is extremely helpful for troubleshooting those issues. Another factor we consider is cost. And I'm not going to name names here, but some APM vendors are prohibitively expensive. I mean, especially when you are looking at scaling your application and you have your monitoring running on more than a few boxes, the cost can just become astronomical and out of control. So we are definitely sensitive to that, and we you're looking for a solution that is affordable within our environment. And a third one here that I want to call out is the user interface, the graphing and the user interface aspect of the application. So I'm a sucker for good user interface, and it's not just because I appreciate when a UI is pretty, because I really like pretty interfaces, but it needs to be functional as well. And as a bonus, a good user interface can help me show other people on our team, especially people who are maybe a little bit less technically savvy than me. I can show them that we've fixed any issue very easily, because I can say, well, the numbers on this side of the graph are higher and the numbers on this side of the graph are lower after we fix the problem. So we're good. So we looked at all of these factors the last time we searched for an APM, and we landed with Instana. We're really happy with it. And right now I'm going to show you what we do and how we use Instana during day-to-day operations. So here's a screenshot of kind of the high-level performance monitoring that we do, that Instana does for us. This is kind of the thing that I'll have up in the corner of my gigantic monitor, and just to keep an eye on throughout the day and make sure everything looks okay. You can see on the left here that there's a raw number of API calls that's happening real time per minute. And this screenshot's kind of interesting because, as David was talking about, we do a lot of transactional API or transactional file transfer. And a lot of these jobs are automated and they run on the hour. And so there's a big spike here. You can kind of see it. It's a little bit small, but you can see at 1400 hours, there's a big jump up because a lot of these systems are configured to run every hour. So you can see there we've got a large number of calls coming in. And then on the right side, you can see the latency of these calls. And you can see that the latency goes up a little bit as we increase load, which makes sense. But we can tell here at a very high level whether we're seeing anything out of the ordinary or if everything looks okay. And the right side of this screenshot is probably the most important for us, because measuring latency is exactly the type of thing that we need to make sure that customers are having a good experience with the system. Like the joke said, if the customer is waiting more than a couple seconds, they might leave. They'll get frustrated, and we don't want that to happen. So the other thing I wanted to call out here is that we use Instana to do alerting as well. The nice thing that Instana gives us is the ability to kind of do all of that automatically. We don't have to set anything up. It will keep an eye on these metrics and let us know if it sees anything that's not normal. If anything goes out of bounds or out of range, we'll get a notification about it. We've got a channel in our Slack that constantly will keep us updated with Instana alerts, which is really, really useful. To talk a little bit more about how we do our account level monitoring, we have written some custom code using the Instana SDK to associate different pieces of metadata with each API call as they come in. So that gives us the ability to filter down by whatever we want. The best use of this is to filter down by our account names or by our users who have account or who have users in that account. And here you can see there's a screenshot of our FTP test account, which is continually running automated tests against the service. So you can see that that graph is pretty flat as far as the usage goes. But we're able to drill down specifically to that user and see performance metrics and see latency and pretty much any piece of data that we want that's only looking at that specific account. So if a user is having a particular problem that we don't see at the high level, we can drill down to that specific user and really troubleshoot just looking at their information. So that is a very big advantage to Instana. And then we can take that information and continually monitor it using application perspective. So you can see on the left here that I'm keeping track of just calls to the API overall. And on the right, we have a perspective set up per application server. So we can tell if any of our application servers are having problems, if there's something specific to a box that we need to investigate. And anything could be created, anything could be set up as an application perspective, which is a great way to keep tabs on something that you know might be having a problem, or something that you want to, that's a very critical piece, component of your architecture that has to, you have to pay special attention to. So it's very easy to get that information isolated and displayed specifically for a piece of the architecture that you need to keep tabs on. So the end result of this is really great. We're really happy with this slide in particular because it shows that we're making we're accomplishing the goal that we set out to do. So each blue blip on the left side of the slide here, it represents an incident where we are not meeting our internal performance goals. So we have some sort of problem that we need to fix, and that is customer impacting. So as you can see on the left side of the graph, before we installed Instana, this was back in, we got Instana running around April of this year. So the left side of the graph, we had not only more blue blips, but we also had a higher time to resolve those. So on the right side, you can see that there are less blue blips and that they are taking less time to fix. Overall, we saw a 57% reduction in the mean time to resolution for incidents, which is really fantastic. And then on the right side of the slide, this shows our downtime incidents. We have a third-party monitoring system that keeps track of whether our API is up or down. And each red line in the green bar at the bottom represents an incident of downtime. So you can see before April 2019, we had a lot of those red lines. We were our uptime wasn't great. It was 99.51%. You know, we were shooting for more than 2 nines here. After April, after we had Instana running, we reduced that to a 99.99% at least. We might even be 5 nines at this point, but we're definitely in better shape. And the reason that we were able to do that is we had better visibility on our problems, and we were able to isolate and fix the bugs that were causing our downtime, and Instana played a pretty big role in tracking those down. So of course, better response times and less downtimes makes for happier customers, makes for a better customer experience. So in the future, the road ahead, we have a few things on the horizon, and Instana is going to play an important role in all of these things. One is we are moving to a redesigned from the ground up version of our API. We're calling it the version 2 of our API. This is probably one of the largest projects we've worked on in the history of the company. And what Instana is going to do is really help us make sure that the new version of our API performs better, or at least comparatively as the old version. We don't want to, take any step backwards in regards to performance. So we are going to be doing a lot of internal testing using Instana to make sure that when we upgrade the API, that we're not going to be impacting our customers negatively. We're moving to a Kubernetes implementation later. We run Docker now, but we don't use Kubernetes, and Instana has built-in functionality for that, and we're excited to start working on that pretty soon. The thing that Instana does now that we're not doing, but we will be doing later, is deployment tracking, which gives you a really great way of comparing performance metrics before and after a deploy, to give us a little bit more visibility on how changes that we make impact performance and impact customers. So to wrap up my section here, I have a few tips for reducing downtime and improving customer experience. One is keep a bird's eye view on system performance. That's the high level view that I have open, usually on my monitor, and I just can glance at, make sure everything's performing correctly and everything's looking good. 2, drill down to specific customers, and this is one of the things that Instana does really well, with just a little bit of work on our side to associate that metadata and to be able to drill, to get that information to drill down into customers. It really helps us to be able to look at specific customers so that if they have an issue, we can look at them specifically. 3, keep an eye on keep an eye on troublesome components or bottlenecks. This is where application perspectives come in really handy for us, because we can look at something specifically that we know is a critical piece of our architecture that needs to be performing well, or we can call out a specific customer. We know they've had problems, or they're a very high value customer. We can keep an eye on them. And then 4, set up a robust alerting system, but only buzz phones when necessary. So we use, in addition to Instana, we use Isinga, which is built off of Nagios, for alerting, and we've configured this to buzz our phones only if necessary. And it's actually been a lot of work to fine tune the system to make sure that it doesn't wake us up when there isn't actually a problem. Because there's nothing worse getting paged at 2 o'clock in the morning when you're on server duty, looking at your phone and realizing that it's nothing, that you don't actually need to take action, and it's fine. So in order to have happier DevOps people, you have to pay a lot of attention on fine-tuning your alerting systems to only wake you up when there's an actual problem. So thanks everyone for listening to me talk for a little bit. I am going to open this up to questions now.
So yeah, go ahead if you, this is David again, if you do have questions, go ahead and put them in, and then I think the other David Rubenstein, I think you are keeping track, going to ask some of the questions that folks are entering.
Yes. Are you hearing me?
Yep.
Okay, good. I was having a little bit of a phone difficulty. Yeah, so I just want to remind, of course, our attendees that now would be the time to submit any questions if they have them through the control panel in the questions tab. Okay, but we have a few already, so let's get started. One person wants to know if you can give some more specific examples of what can be found with user-level tracking and what you did find.
Yeah, I can probably take that one. Yeah, so the user level tracking is really helpful when you get these situations where one particular customer comes in and says things aren't working right, something's wrong, and you're looking at your overall metrics, you're looking at your alerts, and everything looks green across the board, right? But that customer is obviously experiencing an issue, and you don't necessarily know right away, is it our issue, is it their issue, is something on their side screwed up, is the network in between us screwed up, or do we actually have a problem? And so being able to tag that user and then go in and look at their specific activity on a platform is helpful. And I'm thinking of a couple of examples. Tom, I'm thinking we had one not that long ago, if I remember correctly, where we had a user who was overwriting basically the same file. He'd written a script to upload data to our service, and he's overwriting the same file over and over and over again. Now on our back end, we actually keep track of the individual copies of a file. So if you upload a file to us and then you upload another file with the same name, we keep both of them. This guy had a bug in his script where he was overwriting the same file. I think it was every second. So every second we would get a new file, the same name, same contents, but the way our backend's built, we were keeping track of all those. And so eventually, on this one particular file, our system started to slow down. And the guy writes in and he's saying, well, why is it taking me so darn long to upload this file? It was working fine a couple days ago, and now every time I upload just this one file, it's taking several seconds. Using the APM and using the user level tracking, we were able to go and identify and say, well, wait a second. So this one database query is taking a really long time for this particular customer. Why is that? And then we went in and delved a level deeper and said, oh, well, that's because this database query is looking at more than 1 million rows in our database and trying to process those, rather than a typical case where it might be looking at 1 or 2 or 5 or 10. And so we're able to work with that customer and figure out that, hey, you actually don't need to upload this file every second. If you upload it, this is a bug in your script, and we're able to solve that particular issue for that particular customer with APM. So there's been a lot of cases like that where either the customer is doing something weird, or maybe something they don't even know about, or in some cases it's an edge case in our platform where there's a case where the customer didn't anticipate, or we didn't anticipate something the customer's doing that's legit. Being able to find those. So a lot of stuff like that. I don't know. Hopefully that answers the question, David. I don't know if you have any others.
Yeah, I just wanted to follow up on that for a second. You're talking about tagging users. So is this an agent-based thing, or so where does Instana actually live in the application?
Yeah, I can talk about that a little bit. So basically what we did is Instana has a plugin that we use. It's called their SDK. It's a little library that we include on our side in our application that allows us to extend Instana's tagging. So Instana is living on our side. It's running in parallel with our services, but we have our code that's sending in a little bit extra information with each call. It's automatically set up to keep track of certain things, but our code adds extra things that it keeps track of. And so every call that gets sent over, data about every call that gets sent over includes what we want to include with it. So it takes just a little bit of code on our side to associate like the account name or the username, but it gives us the flexibility to do that.
And by the way, Tom, we should mention too that we've put up a blog post on the Instana site,
right, yeah.
On how to actually do this. So it's probably a little bit nerdy and a little bit technical for this webinar to how to actually achieve that user level tracking. But if you're curious, there's a blog post that actually goes through the code and goes through the process of how to do it. So you can look that up.
Yeah, I think it's the third link on the slide that we're looking at right now, instana.com/exavoltblog.
Excellent. So curious, does that add any particular overhead to the application?
As far as we can tell, it doesn't. It's very, very performant, and it's not a lot of code to make it do that. So it is extra code, but it runs very quickly. So as far as we can tell, there isn't any additional overhead doing that.
Mm-hmm. Interesting. Okay, the question came in. It's kind of a yes or no, I guess. Can you monitor monolithic applications as well?
Yes. So definitely Instana was designed from the ground up really to handle like the more kind of modern architectures, but we have in many cases and current customers that are still using monolithic architectures. We monitor those without problem. In fact, a reason why a lot of our customers, look at Instana in the first place is when they're, currently using the monolithic architectures and they're looking to kind of move to the more cloud native stacks. Instana has a good way of kind of helping them bridge that gap, monitor the current state as well as the new. And with that, we also we have a great, on-premise monitoring capability as well. It's pretty much identical to our SaaS version. So we're able to handle, any type of environment that a customer or prospect might have.
Great. Okay, so I'm going to put out a last call for questions now. And while we're waiting to see if anybody else has anything else to ask, I'll just kind of go around the horn real quick. maybe each of you can give me a 30-second takeaway that our attendees can have top of mind when they leave. So what do you say we start with Tom, perhaps?
Sure. I would say probably the biggest thing for us is making sure that we can drill down to specific users and be able to troubleshoot problems that they have specifically, because there's so many edge cases, so many different ways people use the platform that we had never really thought of, that it's really important for us to be able to look at accounts specifically when we troubleshoot.
Mm-hmm. Excellent.
You know, I'll
David?
jump in there. I'll jump in there, Tom. That's mine as well. But now I've got to come up with a different one. But one of the things that we didn't mention actually a lot that is important to that is the fact that Instana doesn't sample. So a lot of APM folks they sample data. So they'll sit in your application and they'll run and they'll look at all of the transactions that are happening, but then they'll only actually send a subset of those back to a representative subset of those back to the APM vendor to display. And so that alone negates your ability to look at user level data. So what Instana does is Instana actually sends all of it back, which gives you that flexibility to look at user level data. So I think that's another really important part that you've got to consider when you're looking at APM software is, do you want a product that samples and gives you sort of a partial view of what's going on, or do you want to actually see everything?
Great. Okay, John, have any final thoughts?
Yeah, I think I would just highlight, you know, Instana was designed, you put the agent in, it automatically detects everything. So really, you know, we automated the whole monitoring process. But we do understand that there are, you know, so many use cases out there, you can't necessarily include every single one. So as Exavault did very nicely, we provide a very, you know, hefty SDK and APIs, so that any of those kind of custom use cases or edge cases, you know, you're able to build that in really quickly, while still getting the benefits of the fully automatic monitoring. As mentioned, we don't do any sampling. There's no partial traces, and we also gather metrics at 1 second granularity. And also, as Tom had mentioned, we do this really without adding any real significant overhead to your code or your environment. And that was one of the reasons why I wanted to have Exavault on here. We're you know, always talking about the automated nature of Instana, and they had a really good use case where they used both the automation as well as doing the full SDK and getting exactly what it was they needed out of the product with the data set that we provide.
Fantastic. All right. Gentlemen, I appreciate your time very much today. So that was, again, Tom Feit, Head of Engineering at Exavault, David Ordahl, CEO at Exavault, and John Skog at Instana. Thanks for being with us today. Also would like to thank Instana itself for sponsoring today's event, and of course all of our attendees who hung in there to hear this most interesting presentation. So until next time, I'm Dave Rubenstein, Editor-in-Chief of SD Times, and so long for now.